All right, so the other day in class, you guys, we started dabbling in the idea of rotational energy. All right, we'll just take a straightforward one to start with, easier than what we even did in class. We got a ball. It's starting up here at some height h. We'll say it's like a marble. Rolls down this hill. And when it gets down here, it is actually doing two things. It is totally moving forward, and it is rotating. So up here, it's got potential energy. Down here, it has two types of kinetic energy. What we call translational kinetic energy, moving forward, and rotational kinetic energy, rotating. So just like always, we'd have energy at point A equals energy at point B. We'd have the potential energy becomes not only the kinetic energy moving forward, but also kinetic energy rotation. So mgh would equal 1/2 mv squared plus 1/2 I omega squared. I said it was a solid marble. So we look it up on our charts. The solid marble is 2/5 mr squared. We'd have mgh 1/2 mv squared, 1/2 2/5 mr squared omega squared. Don't lose the omega squared there. Some nice stuff happens. Mass drops out. These 1/2s cancel out even. So we get GH is 1/2 v squared plus 1/5 r squared omega squared. And there's the problem. We have v and we have omega. But v is equal to r omega. So right here where we have r squared omega squared, we can plug in v squared. So that gives us GH equals 1/2 v squared plus 1/5 v squared. You have to get a common denominator, so that would be 5/10 v squared plus 2/10 v squared. So GH will be 7/10 v squared, or v would equal the square root of 10/7 GH. Nothing spectacular, just an extra term there for kinetic energy. The interesting part is if we compare it. What if it hadn't been rolling? What if instead of having a ball roll down here, what if we'd had this same hill, but it had been a box, and it slid down without friction? We'd have the potential energy at the top become the kinetic energy at the bottom. mgh would equal 1/2 mv squared. Mass would drop out. And we'd get v is 2 square root of gh. Compare these terms. 10/7 is less than 2. The ball is literally traveling slower because some of its potential energy wasn't used to make it go fast. Some of its potential energy was used to make it rotate. If there's some of this energy is hidden inside this kinetic energy term, which means there's less energy available to make it go forward. Rolling something down a hill will always make it go slower than if you could slide something without friction down a hill, because you're just using some of that energy to rotate it instead of to make it go fast. Right? That's scenario 1.